Hi. So in this session, I want to build a random forest classifier. I'll be using Iris dataset, which I have already imported. To split my data, I use test size is equal to 0.33, which means 33% of my data will go into testing and remaining data will go into training, right? So random forest is present in the ensemble module of sklearn. Okay. So first I'll have to import random forest classifier. Let us make the object of random forest classifier. So if I see my object, so there are few properties. Criterion is again Gini index, right? So basically random forest is a collection of trees. Okay. So I have another property that is n estimators, right? So this n estimators is the property that how many estimators, how many decision trees I want to make, right? So if I pass n estimators is equal to 10, let's say, so my random forest classifier will be making 10 trees and will be voting among those 10 trees, right? So n estimators is the property which tells a random forest classifier as to how many decision trees it should build. Okay, so some of the other important properties are this n jobs. n jobs basically means कि हम अपने कंप्यूटर में से कितने प्रोसेसर्स को यूज करना चाहते हैं, राइट? सो फॉर दिस टास्क हाउ मेनी प्रोसेसर्स आई वांट माय कंप्यूटर टू यूज. If I pass n jobs is equal to none, this means I am just assigning my one processor to do this task. But since in random forest there is lot of work to be done, there are so many trees to be built, right? So it's always a good idea to pass n jobs as -1. What -1 means is to use all the processors of my system, right? To use all the processors of my system. If we pass n jobs is equal to -2, that means use all the processors except one. Okay, so just leave one processor and use all the remaining. But I will pass n jobs is equal to -1, which means that use all the processors. Okay, so now let's fit our data. Okay, so let's check score as well on testing data. So my score comes out to be 0.96. Okay, one thing that I want to point is if I run my code again and again, I will get different score. Okay, so let's do one thing. Let's run my code 10 times. So if I run my code 10 times, there is a possibility that I might get different score each time. Okay, so let's print our score. Okay, so some of the times I am getting 0.96, once I am getting 0.98, and once I am also getting 0.94. So there is a possibility that I might get different scores when I rerun my code, right? Let's rerun this again. So I'm getting a different score once again during this 8th iteration. So why does this happen? Why we are getting different score? If you remember, there was a property random state in our train test split function. So what it did, it made sure that every time we rerun our code, same points go into training and testing, right? Similarly, as we know that for a given problem, there can be thousands of decision trees that can be made, right? So if I have passed n estimators is equal to 10, that would mean that it would randomly pick those 10 trees. Out of those thousands of trees, it would be randomly picking those 10 trees. So every time I run this code, there will be different trees that would be picked, right? So there will be different 10 trees that would be picked out of those thousands of trees. To make sure that every time those same trees are picked, we can pass random state here also. Random state is equal to, let's say, pass it 0. So now if I run this code again and again, my result is going to be same. Okay, so as we saw over here, there was this random state which was none, but since now we have passed random state, our answer is going to be same every time, right? No matter how many times you try, the score is always going to be 0.94 now, right? Because random state has been passed 0. If I change random state again, so it will be same again, but it might be a different answer, right? Like we are getting 0.98, but it will be always be 0.98 because same 10 trees will be picked every time for random state is equal to 1. I hope this is clear. You can try yourself applying random forest on different data sets. You can use the hard dataset which we use during decision trees. You might also use other classification datasets like breast cancer dataset, heart dataset, wine dataset, and the iris dataset which we have already used in this session. So now that we have already studied few classifiers like logistic regression, decision trees, random forests, you can start applying them on various datasets and start comparing which one gives better result, right? And we are going to study many more algorithms in the coming sessions, but I hope now you have started to get the essence of machine learning and the things have started to make a lot more sense now, right? So I suggest you to practice as much as possible. This will definitely help you understand it more and you will be able to appreciate and enjoy this course even more, right? So I'll see you in the next session. Thank you.